All right, let's boot this up. Welcome to the Explainer. Today, we are taking a totally different approach. We are treating your exam preparation exactly like a high-stakes Silicon Valley-style hackathon. I'm going to be your lead dev for this session, and our target mainframe today? It's the Cambridge 9706 accounting syllabus, specifically that notoriously tricky closure of business unit prompt. I want you to think of the examiner as a highly complex firewall, right? And your calculations, your structure, your analysis, that's the code we need to deploy to successfully breach it and get those top marks. So, let's initialize.
Now, before we start typing out any code, you might be wondering why we are targeting this specific module. Well, did you know that mastering this single topic, marginal costing for the closure of a business unit, accounts for a massive 15% of your total marks in Paper 2? Seriously, 15%? That is a massive chunk of data. To put that into perspective, if your code is weak in this one specific area, your entire system grade crashes. There's no way around it. But hey, don't worry, because we're going to locate and patch every single one of those vulnerabilities right now.
Okay, real quick, here is our technical roadmap for today's hackathon. We'll start at the system terminal, move on to debugging the command matrix, then compiling the patch, hitting the beta testing arena, and finally, code deployment. Starting with phase 1, the system terminal. To really understand how to execute the absolute perfect exam response, we need to look at two of our junior coders competing in today's hackathon. Let's call them Dev Alex and Dev Sam. Honestly, these two perfectly illustrate the classic cognitive gaps we see time and time again in the exam hall. So, look at Dev Alex. Alex has excellent raw data inputs, like they can calculate the contribution margin perfectly every single time. But poor analysis causes massive memory leaks when they try to evaluate fixed versus variable costs. The logic just falls apart. Then, on the flip side, we have Dev Sam. Sam is great at logical loops, totally understands the rationale behind closing a loss-making unit, but completely fails the strict syntax precision rules required by Cambridge, and the source materials are super clear on this. Successful candidates absolutely have to demonstrate competence across all domains: knowledge, analysis, and evaluation. If you're only pulling data like Alex or totally ignoring the formatting syntax like Sam, the firewall rejects your code, period. So, establishing our baseline is absolutely crucial here. Consider this an examiner alert. The reports warn us that candidates consistently confuse key terminology. And let's be real, you cannot execute an extended analytical response if your core definitions are bugged from the start. Marginal costing requires systematically separating variable costs from fixed costs to calculate the contribution margin. Why? Because if a unit generates a positive contribution, closing it might actually harm your overall business profit, even if that specific unit shows a net loss. It's a classic trap. You must explicitly define these terms before you start throwing them around in your extended responses. Basically, consider this your primary variable declaration. Don't skip it.
Moving right along to phase 2, debugging the command matrix.
Okay, so we've got Dev Alex and Dev Sam frantically mapping out their response outlines right now. They are trying to secure what Cambridge officially calls method marks. And this sequence you see right here, this is your golden algorithm. Step 1, deconstruct the prompt. Step 2, extract the relevant data. And actually, scratch that. It's not just extracting data. It's specifically separating the apportioned fixed costs from the unavoidable fixed costs. That's the key. Step 3, select your analytical framework. Step 4, execute with crystal clear notation. And finally, Step 5, verify your results and present them using the correct terminology. Remember, in Cambridge accounting, the systematic processing matters just as much as your final answer. If you just magically jump to the final number without showing this step-by-step sequence, the system throws an error and you lose out on huge marks. So right now, Alex and Sam are debating how to optimize their format. And I need you to listen closely. Poor presentation acts exactly like a fatal syntax error. The Cambridge procedural framework enforces incredibly strict conventions. You absolutely need proper headings, the correct terminology, appropriate formats, and really clear annotation. If you're working out as just this messy, chaotic block of text that mixes up marginal and absorption costing without any clear headings, well, the examiner firewall cannot read your logic and your grade gets rejected. Think of clear annotation as your code commentary. It tells the examiner exactly what your logic is doing at every step. All right, we are entering phase 3, compiling the patch. But actually, I'm going to halt the compile screen right here for just a second. Before we push this final patch to secure maximum marks, you need to optimize your own system feed. Subscribe to Ace the Exams at the handle at Ace the Exams right now and turn on all notifications so you don't miss any of our weekly system updates. All right, back to the terminal. Okay, so our developers, Alex and Sam, have just hit a wall. They encountered a critical logic error mid-argument. To patch this, we are deploying the deconstruct solve evaluate loop. This is basically your peel syntax structure for accounting. First, you identify the given information. For example, maybe a department is making a $10,000 net loss. Next, you break it down into logical steps. Are those fixed costs unavoidable? Will they exist even if we close the department? Then you solve systematically, checking for reasonableness as you go. And finally, make justified recommendations on whether to actually shut it down. By using this strict logical loop, Alex and Sam instantly debug their messy paragraph and upgrade their argument into a high-scoring response. And to take it to the next level, our team uses this exact 3-column table to evaluate evidence quality. Comparative analysis in these exams requires identifying similarities and differences, supporting each of those comparisons with hard evidence, and then, crucially, this is the part most people miss, drawing conclusions about their relative importance. So how do you actually evaluate evidence quality? You do it by identifying limitations in the data, questioning the assumptions, and evaluating qualitative factors, things like employee morale or long-term supplier relationships. That is exactly how you structure a bulletproof evaluative paragraph that the firewall simply cannot block. Welcome to Phase 4, the beta testing arena. It's time to put you in the hot seat. Audit 1 is officially initiated. Take a look at the data chart we're pulling up. When you are evaluating a business unit closure, your data interpretation skills must be rapid. Like, you have a 60-second visual countdown clock in your head to extract those relationships instantly. If we see a sample student text block that just lists numbers out without ever explaining how a lost contribution margin impacts the wider business, that is a massive syntax failure. You can't just parrot the numbers back. You must extract, interpret, and then draw an evidence-based conclusion. Let's dig into the bug report here. These are the top 3 fatal examiner traps, pulled straight from the Cambridge Principal Examiner reports. You want to avoid these at all costs. Bug number 1, using the wrong approach for the context, like using absorption costing instead of marginal costing for a short-term closure decision. Total system crash. Bug number 2, candidates simply ignoring formatting and presentation conventions. We just talked about how deadly that is. And bug number 3, answers that are generic and lack specific context. If your answer could apply to literally any business on Earth, it's not specific enough to the prompt. Any single one of these fatal bugs will completely destroy your grade, no matter how good your underlying math is. You have to stay vigilant. And finally, Phase 5, code deployment. Our team has successfully debugged their responses and completely optimized their formatting. So here it is, your ultimate cheat sheet architecture. Define, execute, justify. First, define your core concepts clearly to avoid those early terminology errors. Second, execute your methodology systematically, showing every single step to grab those method marks. And third, justify your conclusions by evaluating both the assumptions and the contextual qualitative evidence. Run this exact script, and I promise you, you bypass the examiner firewall every time. Make sure you subscribe to Ace the Exams at AC the Exams right now. Click that notification bell and leave a comment below with your specific subject and level so we know what mainframe to hack next. But I'll leave you with this final query to compile in your own time. If a struggling business unit is generating a net loss, but it's still providing a positive contribution margin, do you shut it down and risk crashing the whole system, or do you keep the server running? Think about it.